Hey sixth graders, this is lesson 8-8. This is all about more with data, and we are going to be using the data from what we did in our last lesson, our median, and then finding our first and third quartiles, as well as our range to do this lesson. We are going to be learning about something called a box plot. The dot plot, which is what this looks like on the left, and the box plot, which is what this looks like on the right, this is the new one, represent the same set of data on this page. A box plot is a graphic summary that shows the median, the quartiles, and a minimum and the maximum values of a set of data. So box plot and dot plot show very similar things, but box plot is just kind of unique because instead of showing all the data points, it summarizes your data points by using the medians and the quartiles. So in which display, either the dot plot or the box plot, in which display is it easier to identify the median and the quartiles of the data? Give a reason. What do you guys think? Dot plot or the box plot? Which one is easier to find the median and the quartiles? I would definitely say the box plot because they're already listed. Okay, in the dot plot, we would have to determine the median and quartile 1 and quartile 3 by doing a bunch of work, similar to what we did in the previous lesson, where here's the dot plot, finding all that information. Here's the median, here's quartile 1, here's quartile 3. It takes some time to figure out, okay? But in the box plot, it's already done for you. You guys can see on the box plot, there's 5 important values. There's the minimum value, that's the low part of your range, your maximum value, which is the highest part of your range, and then you have your median, which is your number that's in the middle, and then we identify the beginning of your box is your quartile 1, and the end of your box is your quartile 3. So all of that is already listed in your box plot. Okay, so number 2 says use the box plot to name the median, the quartiles, and the minimum and maximum values of the data. Explain how you know. Well, I'm not going to explain other than just on the video I'll say it. I know because it's all listed there. So our minimum value is 1. If you look at the graph, minimum is labeled right here with the circle. It's above the 1. Our maximum value is 9 because when you look at the box plot, that circle over here is over here above the 9. Our median in the middle is 5. Because the median is that line in the middle of the box that's above the 5. And then we also have quartile 1 and quartile 3. Quartile 1 is the beginning of the box, and it looks like it's right in the middle, if I extend that down, of 2 and 3. So it's 2.5 or 2.5. And then for the other side of the box, where it ends, quartile 3 is right here in the middle of 7 and 8. So we'll call that 7.5 or 7.5. So that's how we know, is just by looking. Okay, so when you draw a box plot, it always looks like this on top of all your numbers. You have your minimum, which is connected to a line. You have your maximum, which is connected to a line. And then you have some kind of box in the middle, and the beginning of your box, here, this is your minimum, this is your max. The beginning of your box is your quartile 1. The end of your box is your quartile 3. And then the very middle of your box is your median. Okay, so that's how a box plot always works. Now, in which display, the dot plot or the box plot, is it easier to identify the range into which one half of the data can be found? And right here, the answer is the box plot. And that's because in the box, it shows half of the data in the set. And I'm actually going to go back to yesterday's lesson to show you what I'm talking about. So right here, the box, this is half of your data. is all falling between quartile 1 and quartile 3. Half of your data, one half of that data falls in this box because of what we talked about in our previous lesson, right? Quartile 1 and quartile 3 are like when you have, when you're talking about fractions and you divide a fraction, first you divide your fraction in half, and then you find the left half, and then you find the right half. Well, you guys can see that right here in the middle, right here, this is 1/2 of your data, okay? Because we know that that's what a fraction is like. If you have 2 out of the 4, that's 1/2. And if this line represents quartile 1 and the other line represents quartile 3, those are the beginning and endings of your box on your box plot, which we have right here. Quartile 1 and quartile 3. This is like saying half of your fraction box, okay? So when it says, is the dot plot or the box plot easier to identify where 1/2 of your data is? Definitely the box plot. That's what that box is all about. Your box tells you, hey, the box plot tells you, hey, there's other data points. Your data, the lowest one's at 1, the highest one's at 9, but half of your data can be found right here above these numbers. That's why a box plot can be important. Okay, so number 4 says we get to make a box plot to represent the dot plot data. All right, so it's going to be really easy to start. My minimum is 23, so I'll put a dot over 23. My maximum is 29, so I'll put a dot over 29. But then I like to write out all my data points so it's easier to find because I have 3 more values. I still need to find my quartile 1, my median, and my quartile 3. So I'm going to write all these data points out to do that. I have 23, 25, 25, 25, 26 and 26, 27, 27, 27, 27, 28, 28, 28, 28, and finally 29. So there's all my data from this picture. What is my median? I have to find my median before I can find my first or my third quartile. My median is my data point that's in the middle. So how many data points are there? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. Ooh, this is an odd one. Odd ones are my favorite because then you can just find the one in the very middle. So it's going to be my 8th one if it's 15. 1, 2, 3, 4, 5, 6, 7, 8. So right here is my median. So I'm going to make a line at 27. 27 is my median. So for my box plot, my line for my median goes on top of the 27. Then I need to find my first quartile by finding my median of my left half of my data. So there's 1, 2, 3, 4, 5, 6, 7 data points. So the 4th one is my middle one, which is 25. This is quartile 1. So I'm going to put the beginning of my box at 25 for quartile 1. And then on the right half of my data, 1, 2, 3, 4, 5, 6, 7 data points. So 4th is my middle right here. 28 is my quartile 3. So on top of 28, I get to put my quartile 3. So now I can go ahead and close my box. And then you get to attach your minimum and your maximum values with these little lines. Okay, so this is called a box plot. I have my minimum on the left, my maximum on the right. My median is right here above the 27. And then I have my first quartile at 25 and my third quartile at 28. And the reason why this is important is because this tells me that half of my data, or 50% of my data, is clustered in this box, okay? Which means that a lot of my data is between 25 and 28. Yes, there was a low point of 23. Yes, there was a high point of 29. But most of my data, 50% of my data, was between 25 and 28, which we can kind of see in the picture of the dot plot, but it wasn't as obvious. Okay. So we're going to interpret a box plot for our next activity. And it says, compare the box plots shown below The box plot at the left shows the number of times the students in Mr. Rayburn's class wore shorts during the summer, or during September, my mistake. The box plot at the right shows the number of times students wore shorts during October. So here's shorts worn in September, shorts worn in October. How do the median and the quartiles for September compare to the median and quartiles for October? So I'm going to put September data on this first line. I'll put October data on this second line. So we have the median for September is that line, which is 5. The median for October is the line right here in the middle, which is 3. Quartile 1 for September is the beginning of our box, which is 4. Quartile 1 for October is the beginning of the box, which is 1. Quartile 3 for September is the end of the box, which is 8. And quartile 3 for October is the end of the box right here, which is 4. So the question was, how do the median and quartiles compare? I would say for October, it was always lower, and for September, it was always higher, right? So we have 5 versus 3, 4 versus 1, 8 versus 4. So September is higher, and then we can say October is lower, okay? So what does your answer suggest about September and October temperatures? Now remember, this was about how often students were wearing shorts. So I think our answer suggests that if September, if all the data points had higher numbers and all the data points for October were lower, we could fairly say that September was likely warmer than October. And I should write this down, but just to make the video go a little bit faster, I'll just explain it talking instead of writing it down. I would say September was likely warmer because all the data points were higher. There were more kids wearing shorts in September, so it was probably warmer. All right, next. It says 3 summaries of data displayed in the box plot are shown at the right. Use the summaries for the next 2 questions. Okay, so we have a quartile 1, a median, and a quartile 3. So it says, suppose 37.79 is a value in the set of data. Where in the set is 37.79? So I'm envisioning, if this is a box plot, the beginning is at 13.5. That's the beginning of my quartile. I don't have the minimum. I don't have the maximum, but I know the minimum is less than 13.5. And if my quartile 3 is at the end of my box, my quartile 3 has to be 44. So I don't know my maximum, but I know it's more than 44. My median is 16.02. Now, based on just a number line, 13.5 and 44, my median 16.02 is going to be way closer. I'm going to draw that median line way closer to the 13.5 than the 44. This is 16.02 is my median. Okay, so I turned this data in the yellow box into a box plot, although I did not have information for the maximum and minimum. But it said, suppose 37.79 is a value somewhere in here. Where do you think it would go? So I would say it's going to go in between. It's like somewhere right here. Okay, I would say if I was going to write with words, again, I'm just going to talk instead of writing all this down just to save time, but I would say it's, where would it go in the data set? I would say that it is inside of the box plot. It's greater than the median, but it's going to be closer to 44 than it is to the median. That's what I would say. So our next question says, how does the range from the median to quartile 1 compare to the range from the median to quartile 3? And what does this suggest about the spread of the data? So I would say from the median to quartile 1, so I would say quartile 1 to median is very close together. And then it says, what about the median to quartile 3? So I would say median to quartile 3 is very far apart. And again, this is, I think it helps to have drawn this visual right here like I did. Instead of just looking at the yellow box, it helped to have that visual there. So quartile 1 to the median, they were close together, but that median to quartile 3, if I label these, it would be helpful. Quartile 1, median, quartile 3. But from the median to quartile 3, they were a lot further apart. So then it says, what does this suggest about the spread of the data? Well, basically, I think it's important to remember that each of these little clusters from quartile 1 to your median, that represents 1/4 of your data. So the range from the median to quartile 3 is a lot bigger. That suggests that the data is a lot more spread out. Okay, so I would say there are a lot of data points between quartile 1 and the median, and a lot fewer data points between the median and quartile 3, because they are so much more spread out here that there has to be fewer data points there. If 25% of your data, 1/4 of your data is shoved all right here, there's a lot of data, okay? But between the median and the quartile 3, they're so spread out that I would say that there's fewer data points there. The numbers are not as close together right there. All right, so next we have a page that says we're going to talk about something called the IQR, the interquartile range. So in a box plot, quartile 1 is often called the lower quartile, and quartile 3 is often called the upper quartile. The interquartile range, or the IQR, is the difference between the upper and lower quartiles, and it's a way to describe the spread of data in a set. So it's kind of like the range that we learned about in our previous lesson. We said the range of Jayla was her high point minus her low point, her maximum minus her minimum. But this time, you're not talking about the range of your whole thing, not this maximum and this minimum. You're just taking the difference between your upper and lower quartiles, or your both sides of your box, basically. So number 9 says we're going to use the box plots right here to answer these questions. Calculate the IQR of box plot A. So for this one, we have the quartile 3, which is 7, quartile 1, which is 3, and if you want to calculate the IQR, or the interquartile range, you take your high point of your box, which is 7, you take your low point of your box, which is 3, and you subtract them. What is 7 minus 3? 4. So the IQR, the interquartile range of box plot A, is 4. Now for B, the high point is right here at 7.5. The low point of that of those quartiles is 1.5. So we're going to calculate 7.5 minus a 1.5, which is 6. So calculating the IQR is very simple. It seems hard because it seems like such a long word. Oh, interquartile range, IQR, that sounds crazy. It's not. It's just subtracting. You take the right side of your box, your third quartile, and you subtract the left side of your box, your first quartile, and your answer is your IQR. So it says compare the IQR of box plot A to the IQR of box plot B. What does the comparison suggest about the spread of data in plot A when compared to the spread of data in plot B? So kind of like when they asked us in our last lesson, having a range for Sophie that was really big and a range for Sophie that was really little, what did that tell us? It told us that it wasn't predictable to get Sophie's, how many baskets she would shoot during a game, but it was predictable for Jayla because her range was a lot smaller. What does the IQR tell us? So it's going to tell us that the middle 50% of the data in A is not as spread out as the middle 50% of data in plot B. So very similar to what we learned before, except instead of comparing all the range, it's just the range of their boxes. So the middle 50% of the data, remember each quartile is 50% or is 25%. Because it's 1/4 or a quarter. So if you have two of them together, which is what your box is, that middle 50% here is smaller, it's only 4. The middle 50% here is bigger, it's 6. So all it's telling us is when you have a smaller IQR, it means that your middle set of your data, that middle 50%, is closer together. It's more clustered together on your plot, and it's more spread apart on box B. Okay, so the data at the right is a new problem. It summarizes the quiz scores for 2 math classes. The quiz was the same for each class, and each class has the same number of students. So we had the morning class versus the afternoon class. Hey, this is like our school. The morning class on their quiz, they got their scores back. The median was 87, and the median was also 87 in the afternoon class. But look at their quartiles on their data. They're different. The quartile for first quartile for morning class was 74. It was higher in the afternoon class. They did better. Their quartile 1 was 81. Well, the third quartile for morning class was 89, and in afternoon class, it was 95. So the question is, suppose a score of 90 or more earns a grade of A. What class earned more A's? Give a reason to support your answer. So I think it's safe to say the afternoon class got more A's. Because even though their medians were the same, okay, if you tried to do a box plot for them, they would have that same middle line in their box plot. In fact, why don't I just do that? Let's do a box plot for A and one for B. I can't do the whole thing. I don't know their high and their low, but I could do at least a box for them. They have the same median right here in the middle, but for morning class, it was 74 and 89, whereas afternoon class, it was 81 and 95. So where is the data clustered? Well, that means that for class B, they got more A's because they had more, their data was with higher numbers. Where in the morning class, oh, I guess I put A and B. This should have said afternoon and morning. Sorry about that. Because in the morning class, their data had a lower and an upper quartile that were smaller numbers compared to the afternoon class. So I'm just going to say the afternoon class got more A's because their quartiles were higher compared to the other class. Okay. So to finish up this lesson, we've got a couple of Puzzle Penguin questions. The first one says, "Dear math students, I was given the set of data shown below." Here's the data. "Here's the box plot I made to represent the data. Can you help me understand what I did wrong?" Okay, so let's check. There's 5 points that you need to know for a box plot. You have to have your minimum, your maximum, your first quartile, your median, and your third quartile. Okay, so you need to have the minimum, which is 21. Did he do that right? Yes. We got the minimum, and it looks good. You need to have your maximum, which should be 30. He did that. Got that. You need to have your quartile 1 and your quartile 3. Quartile 1, let's figure this out. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So it's an odd number. So let's see, half of 10 would be 5. So we're looking at the 6th one. 1, 2, 3, 4, 5, 6 right here. So here's my median. I should write that down. Median should be 25. Ooh, I see something he missed. He did not identify the median. Median, there should be a line right here at 25. Let's make sure he did the quartiles though. So the left half of the data, 1, 2, 3, 4, 5, the middle of that would be right here for quartile 1. Should be 22. And does he have the line at 22? Yes, he does. He did that. And for the right half of the data, that's where quartile 3 would be. 1, 2, 3, 4, 5. Right here is the middle, 26. So quartile 3 should be 26. Is there a line at 26? Yes. So Puzzle Penguin did everything right. I'm going to say all looks good, except you forgot the median line at 25. So Puzzle Penguin did okay. He just lost one little point. He forgot the line for 25 to show the median. Ah, we forgot this one. Okay, so our last question for today says, "Dear math students, I was asked to draw a box plot to display the set of data at the right. The box plot I made is shown below. Can you help me understand what I did wrong?" Oh, okay, so it's the same idea. We need to check for the minimum, the maximum, quartile 1, quartile 3, and the median. Okay, well, I see minimum and maximum. I see all 3 lines, the beginning and ending of the box, and the median. So let's check if the numbers are correct. Okay, are all his data points in order? 203, 204, 205, 206, 207, 208, 209. They're all in order. The minimum should be 203. There's a big dot over 203. That looks good. The maximum is 209. There's a big box over 209. That looks good. The median should be right here at 206 because that's the middle. That's where the line is for 206. Median looks good. Quartile 1 should be the middle of the left data, which is 204. Ooh, no. That is a mistake. The quartile 1 should be right here at 204. So this box should be extended out to there. And then quartile 3 should be the middle of this data over here, which is 208. No, Puzzle Penguin did it wrong again. This should be a much bigger box than it is. So we can tell Puzzle Penguin that the minimum, the maximum, and the median look good. However, quartile 1 should be at 204, and then quartile 3 should be at 208. So Puzzle Penguin messed up on the upper and lower quartiles, but everything else looked okay. Okay, you guys, so I know this is a lot that we're doing with the data, but hopefully it is making sense to you. We'll talk to you later.